Okay, so this video is going to walk you through some of the analysis that we did for Lab000c, spherical science, the one where we have a variety of different ball bearings of different sizes and material, and we collect data on them in an attempt to actually find the density, among other things, and show that it's a material property that's consistent for any of the individual materials regardless of size. The other thing that we were doing was we're using this to get a feel for the very high power of spreadsheets and when you want to use them, i.e. when you've got a bunch of tedious calculations to do. Now, real quick, because it's a personal axe I have to grind, let's go up to the top where it says Untitled Spreadsheet, and let's call this Lab000c, and I'm going to put my name, Sanchez. Put your name instead. I cannot tell you how annoying it is for everybody to send me files that are named my spreadsheet or whatever the default thing is. Untitled Document is also not a good one. So, when you're working with a document, it helps to do that pretty much right away, just so now you've got a unique name for it and we know exactly what it's for. It's Lab000c, and to whom it belongs, that is Sanchez. Okay. So here, I'm going to start putting in some of my data. So we had materials. Let's see, I had nylon, and I had 5 of each of these. Now, you may have only gotten 4. I'm going to use some of the data that I've collected, possibly with some more advanced equipment, but that's up to you. One of the things that we should be able to do, I can drag this down. That's 4, 5. There we go. Instead of having to type it each time, I can actually write it once, and then I can drag it down. So the key to this is, and we're going to be using this quite a bit, this happy little blue square at the bottom right of whatever cell you're working with. And this is also true for Excel, and I think it's the same in numbers, which is the Apple version of this. 3, 4, 5. So there's steel. Here is brass. And you can put these in any order, but this video is to help walk you through that. The nice thing about spreadsheets are once you get used to working with them, they make it where you don't have to do near as much work and you get much prettier results. Now, we're still going to go through in class and I'm going to require you all to be able to do all of this by hand, but these give you some additional options. I'm going to go in and I'm going to put in data. So we have the diameter measured in centimeters and we have the mass measured in grams. I'm going to mark those. Okay, great. Now, as a quick reminder, on all of these, if you look, it keeps putting stuff on the left-hand side of the column. And that's a little clue as to whether or not the spreadsheet knows that it's a number. If it's on the right-hand side, like watch what happens when I put in this, 0.3. It's on the right-hand side of the cell, which tells me that the spreadsheet knows that that's a number and can do math on it. What if I put in the next one where it's 0.6 and I put centimeters along with it? You'll notice it's no longer on the right. The spreadsheet no longer realizes that this is a number and cannot do any math with it because of that centimeters. So I'm going to remove that, and look, now it's on the right. Now that's a good thing to keep track of because that lets you know whether or not you can do math on something. Now I'm going to start filling in the data as I go down. You probably did not measure the tiniest one in class. I told you kind of to avoid that. I've got some okay measurements on them, and I'm going to see what we come up with by actually doing analysis with them. If you were not here on the day in class, you are welcome to use the results that I have here. This is good sample data. In fact, it's usually what's posted on the website with sample data in case you missed this. Now I'm putting the diameter in for each of the spheres that we looked at, the ball bearings. Pardon me. The wood is actually a bit larger because they're not really ball bearings, they're actually craft wooden spheres. 0.02, 0.15, 1.22, 58, 0.11. This will probably take you a bit longer to get put in. I have a lot of experience with spreadsheets, and so this goes a little faster for me. More insights. That sounds great. I'm going to dismiss you. 71, 2.3, I think. Am I back where I'm supposed to be? There we go, 2.3, 5, 20, 31, and 48. Now, I'll remind you when we went through this in our actual lab materials, the things that I gave you may not have been the best scales in order to make these measurements. I have some additional scales where I got some finer measurements, and I'm going to use that data as we go through here because that's the sample data that I have. You are welcome to use your own data, or if you'd prefer, you can use my data as well. It's whatever you'd like. Now, one of the things that I wanted to do is I wanted to go through and I wanted to show you how to get Excel to do math for you. We want to analyze this data both analytically, that means mathematically, which is one thing that you all are probably a bit more familiar with, and we also want to analyze it graphically. We're going to generate some graphs, and I'm going to walk you through how to do all of that here. First, however, we want to try and find the density in order to find this analytically. For that, I need to get the volume. I've got the mass here. So I need the volume of these spheres. Well, on the sheet and in class, I gave you that the volume of a sphere is equal to 4/3 pi r cubed, where r is the radius. We didn't measure the radius because it's really hard to measure radii in real life. We measured the diameter. So here's what I'm going to do. I'm going to make a column marked r because I need the radius, and I'm going to hit equals. And that tells the spreadsheet I want it to do some math. I'm going to teach it what math I want it to do. So I'm going to click here in the diameter, just this first one, and I want to divide that by 2 because the diameter divided by 2 is our radius. Now the divided by sign, if you have a number pad, is right above the 8. It's the /. It is also right by the right shift. So that's your divided. And then just type 2 and hit enter. And you'll notice that 0.3 divided by 2 is 0.15. Now, you may be thinking, great, am I going to have to type that for all of them? But remember what I mentioned earlier, this blue box down here. Grab it, left click, and drag all the way down. There we go. This just went through and did all of this for me. You can see here, we've got 5 divided by 2 is 2.5. If I have 0.4 here, then it gets divided to 0.2. We just did this entire column of, what is that, 20 data points? All of that done for us immediately. Great. But I don't want just the radius. I'm going to use the radius to find the volume. So here we go. I'm going to say volume, capital V, and I'm going to mark that it is in centimeters cubed. Okay? Since we can't put the units in with our numbers, we want to title our columns, and we know that everything in this column is a radius and is measured in centimeters. So we have all the information we need. Now we're going to teach the spreadsheet to do a more complex calculation, but it's still a calculation. I can get the volume of a sphere, which is what each of these are. I'm going to hit equals to get the spreadsheet to do some math for me. And I want 4/3, so I like to abuse parentheses, but I'm going to do 4 divided by 3. Pardon me. It's even doing me a favor and telling me that that's equal to 1.33333333, etc. Then I'm going to multiply that. That's 4/3 times pi. The times button is the little asterisk. It's Shift 8, for example. So at least on my keyboard, you want the little star, the asterisk. So that's going to be times. You can either type in 3.14159 for the spreadsheet, or you can actually get it to bring up pi by typing pi, open parentheses, close parentheses. That is actually code to the computer, the spreadsheet, that says, hey, I want you to put pi in here to the 10 different decimal places that it knows. Okay, so we've got 4/3 times pi times, we want the radius cubed. Now I'm going to go ahead and put a parentheses, even though I probably don't need it. I'm going to click on my radius, and I'm going to do Shift 6 for the up caret, the little arrow up. And then I'm going to put 3. That means that I'm going to raise the radius, this square that I've chosen, to the 3rd power. I'm going to close my parentheses. I like doing that if I'm going to tack anything else on the end. I know that it's not going to be added to the raised to the power of. Anyway, there we go. I'm going to hit enter. It takes a moment. And now we have our volume. Great. Now that I've got this, I can go through and I can drag this down. This is the sort of thing that would take you a while to calculate all 20 of them, but here's the power of a spreadsheet. I drag that down, and now we have all of the volumes. Great. Now, I was in a bit of a hurry. I should go ahead and mention this. I like to put raw data in columns right next to each other. So you see that these are right up next to each other. You may be wondering why I skipped a square here. That's because whenever I do calculations, I like to keep those separate. If you're doing a full lab report for me for one of my classes, usually the AP classes, I will point out to you that in one section your raw data goes in and any calculations go in a different section. So having them separate is helpful. You can always add one by, if I click on E here, I can right click and I can do insert one left, I believe. There we go. And you can actually insert a space. So if you have them back to back, you could click on D and insert one to the left. It'll push everything over to the left. I don't actually want that, so I'm going to delete column. And there we go. I deleted it back. Okay? You can do that at any point. You can also do that with rows. So you can insert rows, but we're not going to do that right now. Okay. Finally, I'm looking for the density. That's going to be in grams per cubic centimeter. I'm going to mark that somehow. So we've got our density. And I find that, once again, doing some math, so I'm going to hit equals. I take the mass divided by the volume. There we go. Great. So my first data point that I've got gave me the following information. I found the density of nylon to be 1.41 grams per cubic centimeter. Now that's the sort of thing that would take you a while to do, but once again, drag that blue box, it goes straight down, and bam, you have all of them. I'm going to do something a little bit special here, averages. So I'm going to mark this column that it has averages in them, and I'm going to go to the bottom of the nylon, which is right here, and I'm going to hit equals, pardon me, and you could manually go through and add them all up and do all of that, although this thing apparently is already identifying that I might be looking to do an average, but you can see when I hover over it, it wants to average all of these things, which is not what I want to do. Here's the nice thing though, you can type in average and hit parentheses, and now it's bringing up some stuff down here, but that lets you know that the spreadsheet knows this term, average, and will actually average whatever you highlight. I want to average all of my values for the density of nylon, because it should be pretty much the same for each of them. Now, you'll notice that my values are not the same for each of them. And we talked a bit about this in class. That's mainly because we don't trust one measurement by itself. If I went with this tiny one, it would be 1.4 grams per cubic centimeter. If I went with this bigger one, that's 1.4 as well, but I've got one down here that's about 1 and another one that's about 1. Some of my data points are a little high and some of them are a little low, and that's common in a lot of the labs that we're going to do. But if I take multiple measurements and I average them, I found analytically my density of nylon to be 1.23, if you'd like, grams per cubic centimeter. The accepted value for the density of nylon is about 1.15, so about 1.2 to two significant figures, which is honestly what I'd probably quote this to. Most of my numbers, if you look at them, are at best two significant figures, so that's not bad. Here's where I'm going to go in. I'm going to go to the bottom of steel. You can look over here. This one gets a little bit darker so you can see where you're at. And I'm going to have it do the same thing. I'm going to tell it average, open parentheses. Don't forget the open parentheses. And then I drag down for all of steel. You can see that it's a little bit darker next to all those. I hit enter. And we get 7.7. Now the actual density of steel is about 8, pretty much exactly. I think it's like 8.05. Now that can also vary on the type of steel and so forth, but for our purposes in class, we went with kind of the standard value, which is 8.05, so about 8.1. I'm going to do the same thing for brass. Great. I'm going to come up here and drag down, grab all of the brass, hit enter, and I found analytically with my data that the density is 8.6 grams per cubic centimeter. The accepted value is 8.5. So you can see I'm not getting everything perfect on here, but I don't expect to get things perfect. In fact, I went through and threw off some of my data a little bit. In fact, you can point out, like on this steel one, it's not exactly 8 grams. This one's not exactly 28 grams, and this one's not 66 grams. I used a scale that only measured to an even gram. All right, on the last one here, we got an analytical value averaging all of these densities. Since they should all be mostly the same, and they appear mostly the same too, we have 0.64. The actual value that we're usually going with is about 0.67, maybe 0.7. It also depends on the type of wood. But here are some of my answers. I've got, analytically, with my mathematical approach, I found the density for each of these and averaged them out to be about 1.2, which is pretty close to the accepted value. For steel, it was 7.7, which is a little bit less than the accepted value. 8.6, which is a little bit above the accepted value for brass, and 0.65, which is a bit below what I would expect for this type of wood. But that's great. So there's my analytical values, okay? And we took the averages of the densities because they should all be pretty much the same. We're going to double check that with our graphical approach. So this is part of the answer that I wanted you to get. The next part, we're going to do a little bit of graphing. So here we go. I'm going to go up to Insert. I recommend that you click off away from the numbers. If you click on Insert and insert a chart while the numbers are selected, then the spreadsheet will try and get smart and predict what you want, but it's almost always wrong. So we're going to go to Insert. We're going to go down to Chart. And I apologize that this computer's a little slow. Come on, computer. I believe in you. Anytime, computer. There we go. No data. If you were selected on something, it might fill it with some data, and it can be kind of a pain to get rid of it here in Sheets. I'm a little more used to working with it in Excel. Okay, first things first, we do not want a column chart. I'm going to go to Chart Type. I'm going to scroll down to a scatter chart, which is pretty much what all of our charts are going to be. Let's see. They like it if you put the series in first, I found. So we're going to go series, and that's going to be our Y values. Now, we talked a bit about this in class, but if we want a straight line whose slope is the density, a measurement of the density, then my vertical axis, I want to be my mass. I'm going to construct a mass versus volume graph. So there's my series, and now I need values for the X data point. So I'm going to drag this down, and you can see over on the left, I'm going down, and all the ones next to nylon are dark. So even though the box is in the way, I can still select it. There we go. I'm going to click OK. That's looking good. Now, we've gone through and we've found that there are a couple things on these charts that might throw them off. First off, over here, use row 2 as headers. Sometimes that gets selected. If it is, remove it. It may or may not throw some things off, but I think it was messing with some people's graphs. Next, go over to Customize. Another one was Horizontal Axis. Treat labels as text. If you end up with a weird, crazy town banana pants graph, check this setting. Customize, Horizontal Axis, remove Treat labels as text. Because then it's not looking at these as numbers and you're not graphing what you think you're graphing. Great. Now we've got our data, and I can set up to have my best fit line, my trend line. Over here in Customize, in Chart Editor, we want to go to Series, and we go with Trend Line. Put Trend Line on there. Hey, there's my trend line. Now the last thing that I need you to do, and this is going to be a common one, you need to scroll down a little bit. There's an option that says Label. I want you to put Use Equation. Now there's some other stuff that you can do. In fact, let's take a moment and go ahead and do that, because good process on this would be that we want to title our chart and we want to title our axes. So this one is taking nylon, and it is a mass versus volume graph. So that's what I'm going to do. I'm going to give it that name. Great. And then for because for some reason it's giving me a slope of 1. I think it's just rounding it a little too low. Let's make the next graph and we'll check this out. So this should be pretty good for what we want. I'm going to click away from the numbers again. And I can shrink this down if I hit Control and hit the minus sign. Got it. No. Oh, okay, I need to click up here in, yeah. I can zoom down a little bit. If you click at the top of Chrome and then hit Control minus, you can shrink things down a little. So they may be a little harder to see, but it'll give you some more room. I apologize. I will try and do future videos if I can on a computer that's a little faster than this. Chart. Great. So I've got a new chart here. On this one, I'm going to put the series values, and this time I'm going to go with steel. So I've got steel. I'm going to select those. My mass is going to be my vertical, my Y values, and then my x-axis is going to be marked with the volumes. There we go. Great. And then I don't have use 7 as headers, which is good. I'm going to go over to Customize, Chart and Axis Titles. Let's just go ahead and do the title here. We've got Steel, Mass versus Volume. Great. Now that I've got that, I'm going to go to Series, Trendline. I'm going to go Label, Use Equation. Okay. Good. The other one's just rounding it to 1, which is a little weird. I didn't expect it to be exactly 1, but that's what we've got. This one is showing me that my slope is 8.09. And as I told you, the accepted value that we're using for steel is 8.05. So we're actually very, very close to the value for steel with our graphical measurement. I'm going to take this and I'm going to move it down some, and I'm going to go ahead and make my other 2 charts, because I want one for each of them. So insert. By now, hopefully you're feeling kind of comfortable that you can do this on your own. Chart type, we're going to go down to scatter. Great. We're going to add our series. Let's see, I need the mass of brass. There we go. Okay. Great. I'm going to take this and I'm going to move it slightly out of the way so that I can get over to my volumes, which are going to be my x-axes. I'm going to go here. There we go. Oh, nope. I've got 1 data point of wood in there. So I'm going to be careful on that. No. There we go. Brass. Great. Great. And then I'm going to go over here. I'm going to label this one. And we've got title of chart, brass, mass versus volume versus vol. Get with the program, computer. Okay. Series, trend line. So there's my trend line. Now, we would normally do this by hand, but this is how you do it in a computer setting. Okay, my slope of my line, which should be my density, comes up to 8.7, so we're a little above the accepted value with our graphical measurement. Okay, great. I'm going to move this one out of the way, and then we're almost done. I could space them out a little bit better. I could also shrink them down some, but that's fine. I'm going to do chart. We've got one more to do. That is the density of wood. And I'm going to move this chart out of the way here. Add my series. I find that it works best if you add the y values first. So your series first. And then your x-axes. I think the times that I've tried to do the x values first in here instead of the y's, it acts a little weird. So I do recommend doing it this way. Great. Customize, chart titles and axes. You know where this is going. We've got wood, mass versus volume. Great. And if you can't mark the axes on this, it's not the end of the world. Hey, stop deleting things that I put in. Try not to read too much into that. Okay, so I'm going to collapse chart title. Oh, horizontal axis title. I'm bad at this. So apparently there's a drop down here. That's where it was hiding. I'm used to Excel. And we can say volume. Seriously. Volume, cubic centimeters. There we go. Now I've got that. Great. And then I can go over here and I can do a vertical axis. So this is where it was hiding on me. We can do mass with an M this time. Hey, remember when I did an open parentheses? All right, there we go. Now I've marked my axes. Ideally, you'd want to do that with each of the others too. I apologize that I was not able to find that because, yeah, I could have been a little more prepared. Finishing this up, we're going to do trend line. Now our trend line is there, great. And we're going to do label, use equation. And we find graphically that my density of wood is about 0.7, probably 0.72, depending on how you want to look at it. I can move this over a little bit. It would be good to go through and add axis labels on the other graphs, but that's okay. Finally, when you're submitting this, so when you actually put it in, there should be a text box. I could go through and I could say the following. I'm just going to type it here in the spreadsheet, even though I'd want the summary outside of the spreadsheet. So I could say something like steel, nylon, wood, and brass in whatever order. And then we could say analytically, so with math, and graphically, so with graph. My steel density is 7.7 analytically, grams per cubic centimeter. And my graph density, we had, I gotta bring back up that, 8.09. Great. Nylon, we found 1.2. And for my graph, it was pretty much 1 even, because I don't see anything with it. It's just 1 is my slope. Wood, we found analytically 0.65. And then in the graph, graphically, 0.72. And then finally brass. Let's see, we had 8.63 analytically. 8.63, there we go. And then finally, it's hidden it on me again, 8.68. There we go. Now, you would actually type that in just in the submission area and then send me a link on this. What you can do is you can go up to share. It'll take just a moment. Enter names or email addresses. There's an option here that says get shareable link. Grab that, and it will actually bring this up, and you can copy it. You can copy link. Anyone with the link can view. If you switch this off to something else, I probably cannot see it. So, at the very least, you need anyone with the link can view. You could also do edit and comment or more, but make certain that I can at least view it with the link. Okay. And then, when you're submitting this in our online system, you can type out these things here, and then just paste with Control-V or right-click and do paste to give me the link to this document so I can double-check it. And that's pretty much what we do. The only thing that I would like overall that we didn't see in the video, and I apologize that I didn't set it up from the get-go, is to mark the axes, but this is all pretty good. In class, I think we didn't do quite as much touching up the graphs, but that's a good thing to do. All right. This is all the analysis that we need for Lab 000c.